Hey YouTube, it's JP Dillon. Today we're looking at about a 1971 or 72 Magnavox model 1T5073, I believe. Let's double check. I can't remember. I think it's a 1T5073. No, it's a 1T5017, which you can't really. Yeah, 1T5017. Anyways. Picked this up from an estate sale. It's filthy. It's been sitting a while. I believe this is made by Matsushita for Magnavox. But anyway, it's got a vertical problem, which I'll show you in just a second here. This is all tubes. No solid state in this one, not even the rectifier. So we got to wait for it to warm up. And it's unusual to find one of these with a CRT that's still alive, because most of these, the CRTs, are long dead. They did not survive well. Got sound, and we got picture. So you can see, he looks like an egghead. We got some major stretch up here, and we have no sweep on the bottom. And if I try to turn up the height any taller, it just folds over more and then goes into an uncontrollable roll. So obviously we got problems in the vertical circuit. So let's crack this thing open and take a look. So here it is with the back off, and you can see it's all tube PCB, unfortunately. Series strain 21AK6. You don't really see much of. 17BR3 I've seen, yes. And the 17, I think that's a 17JZ8 back there. That's our vertical amplifier, so that's definitely the section we're going to focus on. And the circuit there is just loaded with those wonderful Rubicon oil caps, which love to leak and explode. So we're definitely going to be replacing some caps today for sure. Pretty clean layout though. Not very cramped. There's like a little tiny rectifier tube in here. Just for grins and giggles, let's go ahead and open it. Looks like somebody's been in here before, because that screw's awful loose. Wonder what else they did. Just when you think you got it, it's not coming out. See, there's your little tiny rectifier tube there. The flyback looks beautiful. There's like no hours on this thing. Most of these CRTs didn't hold up, and so every one you see has just got a dead jug, and they would hit the trash because they were small enough to. So the fact that this one survived is pretty good. Just about all of its original tubes, they're all Magnavox labeled, as we can kind of peer in here. And even tubes in the tuner. So there's no solid state in this thing at all. It is absolutely tube. Probably one of the last all-tube black and white sets made. And if we peer at the CRT here, we can definitely see that that's made in Japan. Trying to see if there's an EIA code or something on here, but I'm pretty sure this is Matsushita. Alright. So now, let's flip it up and take a look at the bottom side of the PCB. This is pretty average 70s Japanese manufacturing. Really good solder though. Somebody's resoldered the horizontal out dampener and the vertical thing. Yes, vertical thing. The rest of these, the soldering looks pretty good. There's no crystallization or flaking or anything like that. And they do have it sectioned. You see these little dividers here that show you what section of the machine is responsible for what. So we have pretty much everything in our vertical section here. All these oil caps and things are going to go, because they get leaky or they explode, and then it's a big piece of fun. I do see something in here. Yeah, those couple of solder joints there look like they got a ring around them like they're about to die, but that's easy to do. So since we're not going to yank the whole chassis, take a little more time than I'd like, what we are going to do, disconnect our CRT, pull some tubes out of the way. This random piece of tape that looks like it used to hold something here. And I'm just going to take out tubes to get to the back where the capacitors for the vertical output circuit are. And this is where having large hands is a problem because it's fairly cramped back here. And then they got these little holders here. These really don't need to come out. Everything I can kind of access with hemostats. Sorry about that. But yeah, all those gray guys back there are going to go. So we're going to take a tabulation here. I see a 001, 022, 033, 047, and 3.1s. I don't see a bypass electrolytic. Let's take a look on the bottom again. Yeah, following our cathode here, I don't see any obvious electrolytics. We've got, it goes in two directions. We have two cathodes, one for the oscillator and one for the amplifier, but the only bypass stuff I see are those films. So let's start a yanking. And we're just going to desolder all these guys here. Start pulling them out. And my hopes are that that will just get everything to work, and most of the time it does. Just about all of these old oil caps are leaky or about dead. I don't think I've seen any that are perfect yet after 50 plus years. Keep meaning to change the soldering tip out because it's kind of worn down. Let's move this guy out of the way so I don't char him to death. Some of these areas are not going to be very fun to access, but that's life. Especially in these wire looms that I'm going to have to take up. But I've just been cranking on so many things this week. I haven't had time to change that guy out. I'm going to need to do that today. And clean the bench up. I get all these pieces of hate mail. Just say, oh, your bench is so sloppy, I'd never entrust anything to you, and a messy tech means a poor tech, and all this stuff. And I guess my comment is a messy bench is a busy one. No time to stop. And although it has slowed down a bit since, I don't know, maybe a year or so, I still repair about 5 or 6 things a day. And the TVs are kind of a break from everything audio, because that's pretty much all I do during the day is audio. Old turntables, cassettes, 8-tracks, amps, speakers. When I first started doing this in the 1990s, there were a lot more sets like this. They hadn't all hit the trash yet. They were beginning to, though. It's hard to find portables because they're trash can sized. And when they broke and people got sick and tired of them, having to fix them, they would just throw them in the trash. And we weren't so much into e-waste recycling and all that then. Okay. Let's see, here's a grid coupling cap here. At least I think that is... Yep, sure looks like it. Alright, just had to make sure. Now I know that I could troubleshoot specifically what part of the circuit is most likely responsible. But based on the symptom that you see, both circuits are affected. The way an old tube set breaks down in my mind is you have the oscillator, which is responsible for the waveform, the shape of the waveform. And basically what that shows up as on the screen is the linearity. The linearity is largely the shape of the waveform. So if the waveform's got peaks on top and is rolled off on the bottom, then you're going to have distortions in the picture, or vice versa. And the amplitude of the waveform is the vertical output. And it, of course, via a transformer has to match impedance with the yoke. And so if you get an old tube set and you find that there's foldover on the bottom and distortion on the top, both sections are going to be affected because you have a nonlinearity problem and you also have a lack of height problem. And typically, lack of height in a foldover is usually caused by a leaky capacitor in the grid circuit excessively biasing the tube. You could have a bypass cap that's defective, a grid coupling cap defective, a feedback capacitor that's defective. I mean, it's all, the vertical works on AC, not DC. When the caps get leaky, things go wrong. Okay. I got a good chunk of these out. So let's see which ones I actually have loose here. Okay. Then they got this. This is probably an integrator here. I hope that's not messed up because I don't know what's inside of that one. This is going to be creative. So now that I know that those are unsoldered, I'm going to come back here with L screwdriver and try to pop the leads out of the board. No, we're not going to cooperate today. Yeah, that one's not going to cooperate. I'm pretty sure that was one I took loose. This one feels a lot more confident in removing. Yep, that one's going to come out a lot easier. That one's going to be stubborn. That one is also stubborn. That one's easy. Maybe that was just one that I didn't hit yet. Yep, so those are 0.1. So we need to go back and check those. Yeah, as soon as I touched on the solder a little bit, this one down here fell out. And then this one over here. There we go, finally got that one loose. Those are the 0.1s. And let's let's see here. We got our 0.33. Next to it's the 0.47. And then there's a 0.001. And then back here is 0.022. And I think there was another coupling that we can't see underneath the HV cage. We'll have to rotate that. Let's see if this one's loose or if I got to touch up on this one too. Yeah, that one don't really want to budge. So let's recheck the soldering on that one. Yep, I missed that one. That one's way down here. And he decouples the plate, so we definitely want to take care of that one. That one's an important one. Let's see if I can get in here without melting the insulation on any of this stuff. That's the fun part. Is not damaging anything. Let me wedge something in here, if I can do that. No. It says no. Let's see, what can I do to make you stay? Oh, let's see if I can just wedge something in here. There we go. Think, man, think. There's one. And there's two right there. Okay, now she should come out. So let's see if that's true now. Oh yeah, she's getting loose. Okay. And then there was another one over here on the side, I believe. Alright, so we got that, which is another 0.1. And I'm just going to mark that on the board down here. And I believe this other one over here is for the sound. And then there's another decoupler that goes in here. That's our grid. And that's a 0.001. Okay, so let's go ahead and start replacing our caps and fire it up and see what happens. Alright, so I'm going to be using these ECQ Panasonics, like Japanese orange drops. And what you do is you basically mimic this footprint. And let me show you what I mean by that. So here we have one, and here we have the other. We want the leads to line up so that it'll go into the board nice and easy, and I don't have to fight it too much. Because as you can see, we have limited working room. This is where you just gotta have the hemostats, because if you don't, you're just burning your time for nothing. And so to aid in doing this, I'm gonna have to trim the leads a bit. And then it should just sink down in there with minimal effort, which is what you want to have happen. And then you can tilt it up a bit underneath and bend the leads over so that it doesn't want to pop out when you go to flip the set on its face to solder everything. At least that's what you're hoping for. So let's see, that's our first 0.001. So this is probably the least exciting thing to do on these old sets. At least I don't find it fun. Recapping's kind of boring. But I want this set to be reliable, so you kind of have to. And so that one has a different footprint. We're going to have to make the leads closer together. Because it is, the lead spacing is much closer on this one, even though it's the same value. Oh, that sucked. Thought I had it in there, and then I released the hemostats and it jumped. Let's get a different pair. I think the tips on these aren't quite right. Shouldn't be doing that. And yes, you got to have really good depth perception to squeeze this thing in here without making a mistake. We'll go ahead and press this down. See if I can get the leads bent over. All right. And then there's the 0.1 that goes in there. We'll see if we can. This one's a little more visible, so I should just be able to eyeball it and get it in there. My neighbor has some pretty gnarly allergies today. Let's clip those down. Yeah, so that one just, I can eyeball the lead spacing pretty good. It's just getting it in there and getting it to stay. Okay, so that should be the components for that side. So this one may be a little bit tricky because there's very limited space for me to snake this in. I'm actually going to try to come from the back side over here and hope I got this right. See if we can sink that in there. Looks like we can. That's good. And I'm sure he's going to want to come up. So I'm going to get my hand underneath there and swing this stuff around best I can here. All right. Yeah, he doesn't look so pretty back there, but we can fix that in a little bit. And then there's another 0.001. Just making sure that that's the right value before I go through the effort of popping it in there. With all these numbers floating around in your head, it's not uncommon to make a mistake, and you could put in a 0.01 instead of a 0.001, and then all of a sudden your vertical waveforms are way off and you're chasing your tail trying to find out why. Everybody's done it, I guarantee it. And let's see, I'm going to be bumping the camera mount, so bear with me here. I have to rotate this guy a little bit. Get him in the right position. That's why that lead spacing is really important. One side. Yeah, so the other one is a little bit far out. So yes, this is a curved screwdriver. I'm going to try to push this lead into the hole here. Don't know how successful I'll be. Oh, so close. There we go. Okie dokie. Got that one down in there. The rest of them should be pretty straightforward. Next we got is a 0.047. Let's see how well we can get this back in here. That one's pretty straightforward. Push this down in here. Push the other side down. Okay. This is 0.033, which is going to look a little funny because I had to put lead extensions on it because this one had short leads. I think I ordered some short leads by mistake. It's still going to go in okay. Definitely going to require a little more effort than I'd like. Bend the leads over a little bit, so hopefully it doesn't fall out of the board. And then the last things are 3.1 microfarad. These ones have some fairly long lead spacing. So we'll see if we get it right or if we don't. A little more space to work my hand in here. And of course I just rip out the 0.033, that's nice. Gotta walk that one back in. Just pressing the leads down so they stay in there. let's do the next one. That one was a lot easier. See if I can raise this a little bit so you can see a little better. I don't know if you'll be able to, but we'll give it a shot. And maybe move this tube out of the way so you guys can see a little better. And we'll install the final 0.1 microfarad. I was going to say that one was easy, but then this came out. Okay. All right. They're all, in theory, in there. So let's solder them up and then let's turn the set on and see what our differences are. And you see, this is just my phone on a mount that I made. And it's still kind of in my face. So if you wonder why I don't have a big camera on a tripod next to the bench to get these views, that's why. It's just big and in the way. I don't have that luxury. Of course, I wonder how many people watching are watching with like a VR headset, which, yeah, that will give you motion sickness. I had one viewer that emailed me and said, I tried watching your channel with a Oculus, and that didn't work out so well. The routing of these wires is really tight. You have to move them out of the way just to be able to get to the area you're working with. It was not a I mean, it's service friendly in the sense that you can work on this board easily enough, but just getting to the edges of the board where all the wire looms are, that's the tricky part. While I'm thinking of it, let me trim off all this excess. Okie dokie. We got those three soldered there. There's a loose joint there. And let's see here. I got this to move out of the way. We got got this here. It's this one over here. And there's a foil trace here that looks a little questionable. This one here. So we gotta, I'm not even gonna bother to ohm it out and test it. We're just gonna scrape it clean a little bit, expose more of the foil, and solder directly to the foil. That lessens the probability that we're going to run into an issue with an intermittent or open trace. Let's take care of this one. And then that joint up here I saw earlier that was kind of dry. Let's see, we got these guys here. We got that, got that. All right, so there's the couple down here at the bottom, which is going to require that I move all this wiring out of the way. Get this one down here. And let's see, let's move this B+ line so I don't destroy the insulation on it, trying to solder this back in here. Okay. Then there should be one capacitor left, which is underneath this fat loom of wires on the bottom here. Yeah, you almost can't see it from this vantage. We got this lead here. Yeah, I don't want to get in there too far. I don't want to melt any of these. There's one. And the other one's at the far corner. And it helps to magnetically charge. Just, rub it on an old speaker magnet or something. Your diagonal cutters. Helps keep stuff from getting lost in the chassis after you cut it. They also have ones that have like a little grabber to them, but I don't have those. Okay. Now we just need to put all this wiring back, route it all back where it came from. Including the giant high voltage lead here. And these guys here. Okay. This stuff up in here. There's a little Bit of lead there I didn't cut. And then let's cut this and this. And I think we're good. All right, so let's hook it up and see if we destroyed it. All right, so of course the operative question now is does it work? We replaced all those oil caps in the vertical circuit. Oh wait, there's more over here too. So let's see what she does. Alright, so we got super high speed. Let me put this on the camera. At least we're almost... Yeah, put this on the camera. Put the camera on the mount. At least this is almost filling the screen. That's good. Okay, so first thing we obviously need to do is slow down the vertical oscillator. That's our vertical hold down here. It's pretty close. Alright, so since we're stretched at the top, I'm going to turn down our linearity. Probably have to readjust this. Yep, alright. Let's adjust our height. Our linearity again, since it looks a little compressed. Readjust our vertical. You have to do this. It's all interactive on these tube sets. And there we got a pretty good picture. Looking pretty nice. Our CRT still has a little life left in it, which is good. The sunshade definitely cuts down on a lot of the luminance.
The new Binghamton couldn't care less where you were.
But it's working good now. Now I eyeballed this, so let's see how close I was. Just eyeballing it based on what I see from people and the like. Let's hook up my little signal generator here. Nailed it. That geometry looks great. And that was just guessing by looking at the separation of the scan lines, which the camera doesn't show, but I can see it really well. So there you go, man. That set is done. We're just gonna clean it up a little bit and then enjoy it. So I hope you guys enjoyed this video. And more stuff to come. When I get a little more time, we'll dive back into the Emerson and then into a Sony dual cassette that's come back yet again. So stay tuned and thanks for watching.